When we get here, I can begin to display the depth blocks. Uh, these are automatically picked up by the OCR, the machine learning optical character recognition, and you can see it did a very good job there. And here is the mask of the prediction from the machine learning engine. Here, we can see that the engine failed by not picking up that mask. So I'm deleting this polygon and extending that one to create the correct polygon. Other things I can do is I can add a comment and say, for example, the depth was wrong in the image, so we can provide that feedback back to the rest of the users. When a comment is added, we then get that feature. There is for example, ability as well to add a depth mark, which I'll show maybe here. There's a depth mark here at 136, so I'll do a point here, and then a new mark is added over here, so we can include then the correct depth. You can see there was some validation if that depth is not within the marks. Yeah, this auto verify basically puts the check marks to the images that we've actually done or said they're exporting. They can also add a scale and then use this scale to measure features. So if we wanted to know what the distance between here and here is, that's 1.2 feet. That's it, very simple. We then are able to export. Once we export, I'm just not going to finish that. We then can go into WellCAD, come into WellCAD, import selected files in the format that WellCAD wants it, and you can see it didn't finish all the export here, but I'll just bring in some of the ones that it finished exporting. Here's the imagery in the corresponding WellCAD format, and now what we'll do is we will align that so we can visualize it in WellCAD and assign a depth. And there is our core imagery, already cropped without the blocks. Now what we'll do from that is bring that core imagery next to the televiewer image so we can actually do our picks with the structural information from the actual drill core available, and then do our structural classification more appropriately and more correctly.